In this video, I want to show how to simplify an algebraic expression involving radicals, but note that I've mentioned even and odd exponents combined. So in this example, you'll notice that the variables have one odd, one is even, and there is a number inside the square root as well. Now we're going to look at each of these individually, and basically we break them down the same way we would if they were on their own. So if I think about the square root of 16, I know the square root of 16 is a perfect square. It's 4. So I'm going to rewrite this as 4. Now I'm going to look at my exponents separately. The even exponents are always the easier ones to simplify because it's a square root, meaning when I take the square root of an even exponent, I'm just going to get a half. So I'm actually going to take the square root of that right away and call that y to the power 1. The only thing left inside of my square root sign then is x to the power 5. And I know this is an odd exponent, so when it comes to odd exponents, I always rewrite those as even and odd. So let's continue. 4 times 4 is 16. I'll still keep my little y to the power 1 out here. I'm going to rewrite this as x to the power 4 times x. And now I have an even exponent. I know when I take the square root of an even exponent, it's going to be a half. So 16, a half of 4 is 2. I'm just going to write these in alphabetical order here. And the only thing left underneath my square root sign now is x. So this will be my answer. Now let's look at another example. When I look at this example here, I notice 18 is not a perfect square. So I'm just going to take a minute and do the square root of 18 off to the side here. So the square root of 18, using the largest perfect square, this will give me 3 root 2. Now when I first look, I notice that 10 is an even exponent. So what I mentioned in the last example, even exponents are much easier to simplify. So I'm going to actually keep everything that was outside my radical as is. I'm going to use brackets just to keep track of what I'm simplifying. X to the power of 10, I'm going to simplify that next. So that just becomes x to the power of 5. Now the square root of 18. Let's just take a minute and fill in our mixed radical that we got for the square root of 18. It's 3, and notice what I'm going to do now. I'm going to keep my 2, and I'm going to rewrite the odd exponent in here with the root sign, because that's the only thing left underneath the root with the 2. Now, here, you'll notice we have x's. We will have y's in a couple minutes. So y to the power 6 here now. Before I look at combining these, let's just take a quick recap of the exponent law. The exponent law, when we have a variable, which is the same right here, common base, and we have exponents and they're multiplied, our rule is to add them. So let's go back here and use that rule. I've got x to the power 2 and x to the power 5. So I'm going to combine those and call that x to the power of 7, 2 plus 5. I have a y to the power 3 still there. Now, over here, I'm going to continue to simplify this. I still have my 3. Y to the power 6, when I take the square root, is y to the power 3. And inside my radical, I've got a 2 and a y. Now, these numbers here can get multiplied. So that gives me negative 6. I have x to the power of 7, y 3 and y 3, so that's going to be y to the power 6. And right here now, I have 2y left underneath my root sign, and that's my final answer.